So this is my quarterly update video for winter quarter 2018 for the BrainPoints project in the Atlantic. My research question is, will intervening with strategies when people are unproductively struggling increase their growth mindset, decrease their learned fixed mindset, and increase self-efficacy? The problem with this is it's hard to know when people are unproductively struggling. It's also hard to define unproductive struggle. So the scoped research question I worked on this quarter is, can we detect with key and mouse data when people are unproductively struggling? Motivation for this project. As interest in computer science increases, the number of students in introductory courses is rising, but these courses have low retention rates. Studies have shown that students gain a fixed mindset in introductory to CS classes. Since failure is a key part of learning to code, this makes students vulnerable. Currently, in computer science courses, programming strategies are not explicitly taught or reinforced. Students are not taught how to cope with failure and struggle unproductively, which leaves them feeling frustrated, incompetent, and closer to giving up. By developing tools that teach these strategies while students are coding, there's an opportunity to reduce the learned fixed mindset and increase retention in introductory CS courses. So through need finding, I visited office hours and found many frustrated stuck students. Many students just wanted to try different things and not fully understand their code. In order to detect struggle when students are programming, we need specific detectable metrics. I hypothesized the following two specific behavior patterns would detect struggle: inactivity and repeated small changes. These behaviors were developed through need finding with a study of 7 participants and time spent observing students in office hours for introductory computer science classes. For inactivity, the metric would be no mouse or keyboard input for more than a minute, and this is hypothesized because if the user is just staring at the screen, they're trying to think, but if they stare at it too long without making changes, they're likely not on a productive path and may be stuck.
Yes, we are open. Gates are shut.
For repeated small changes, this detection metric is repeatedly making unnecessary small changes or no change and rerunning code. If the user adds or deletes less than 15 characters and reruns more than 3 times with an error on the same line or failing the same test case, they would trigger this metric. If the user continuously makes small changes and reruns, this indicates they are flailing because they aren't understanding what their error is and are hoping small changes will fix it so they don't have to understand. I conducted a study with 4 participants to investigate these hypothesized indicators of struggle and better understand general behaviors while struggling to code. To validate my hypothesized indications, I recorded every time one of these metrics was triggered, and if the user was struggling productively or unproductively at that time. I used spatial data along with the user's computer screen to provide context to determine if the user was unproductively struggling. In general, I used negative valence, high arousal, and little to no progress on the coding problem to indicate unproductive struggle. My findings related to inactivity. Participants 1 and 3 displayed inactivity during both productive and unproductive struggle. However, in both cases, the inactivity towards the beginning of the coding session was productive and towards the end of the coding session was unproductive. Figure 1 and 3 showed the instances of productive struggle and unproductive struggle over time. Participant 4 was never inactive for more than a minute, so we never triggered this metric, and made consistent productive progress. Participant 2 never struggled unproductively, even though they had 3 periods of inactivity. 2 of these pauses were spent writing out the problem with a pen and paper, so although they appeared inactive by the computer, they were actually thinking out the problem. Due to participant 2, the struggle states of participants during inactivity is 50% productive and 50% unproductive, which can be seen in figure 3 here. So findings related to this repeated small changes. 2 users, participant 1 and participant 3, made repeated small changes and reran their code. In both cases, this happened in the last quarter of the coding session and continued until the end. The users never recovered from entering this stage. Both participants didn't have any errors, but they were failing a test case, and in both cases, the users were unproductively struggling. This figure shows the struggle state of participants during repeated small changes. So there are definitely limitations to this study. Since it was preliminary testing, it's still unclear if these indications of struggle work in all cases. However, this experiment provided some validation for both metrics and provided indication that it is in fact possible to detect unproductive struggle with keystroke and mouse data. One of the largest limitations in this experiment was that there is currently no validated way to define when a person is unproductively struggling. Therefore, the labels of productive and unproductive struggle are somewhat subjective. The inactivity detection metric did not work in all cases, and while the small changes metric worked in all cases, the sample size was too small to draw significant conclusions. This experiment can, however, inform future experiments that seek to find behaviors indicating struggle. There is indication that both metrics, with refinement, could indicate unproductive struggle, and this experiment model can also be used on other hypothesized metrics. Once unproductive struggle is detectable with key and mouse data, it will be possible to intervene at appropriate times with appropriate strategies. These interventions would ideally reduce time participants spend unproductively struggling, reduce the learn fixed mindset, and lead to increases in self-efficacy. This past quarter, I learned a lot about working on my own and owning my own project. I also learned about scoping a research question and running a study to inform that question.